Let's try to understand how to reduce the size of a Pandas data frame. Now, what typically happens is when you try to import a data set, it could be from a CSV file, it could be a database table, whatever it is. When you try to import a data set into Python, that is Pandas, Pandas kind of tries to play safe and assumes and allocates a data type that is much larger than what is needed to store that data. For example, say we have a code, I've written a piece of code that imports this particular data frame, which is dataset, which is churn modeling underscore m.csv. So we have imported pandas, we imported numpy. We're using pandas.read.csv to import the dataset. So this dataset df, data frame df, contains a column called age. Now, if you make sense out of it, any age column, any variable such as age can take values between say 0 to 100, or in extreme case it can go to 0 to 125. Yeah. Now to store this kind of a column, this kind of a data, we only need a data type such as int 8. Now int 8 is more than sufficient to hold values between minus 127 to plus 128. But what Pandas does instead is it stores all these columns, all the numeric columns, it stores by default, it gives a value, it gives a data type of int 64, which is not required at all. So what is the implication of this? Now if you give if this particular column is taking the data type int 8, each of the cells in this column is going to require 8 bits of memory, that is 1 byte of memory to store. Whereas if you store it as int 64, every cell here is going to occupy 8 bytes, right? So this is going to occupy much larger space. Now if you do this for if this particular data frame has a lot of rows inside it and many more columns, and this applies to all the other columns also, by doing this is going to occupy a lot more space overall, and that in turn is going to cause all the subsequent data wrangling operations, as well as ML model training operations to take up a lot more time than what is needed. So by reducing the overall size of the data frame, we can bring down the processing times that will be taken by your whichever logic that you are running. The processing times will come down drastically. Now before we move on, now how did we determine that int 8 data type can store values between minus 128 to 127? Now this, in order to understand or calculate this, you need to understand how computer stores data internally. We know that computer stores data in form of binary format. So what int 8 means is it allocates 8 spaces in memory, and each of these spaces, 1, 2, 3, 4, 5, 6, 7 and 8, right? 8 spaces, and each of these spaces can hold either the values 0 or 1, and each of these locations refer to some power of 2. So this is 2 power 0, this is 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Now how does computer store the data? Now to store a value say 1, it will store it as, give a value of 1 here, all the other cells will be 0. Likewise, to store 2, it will give a value of 1 here, all the other cells will be 0. So what does this mean? So this is 2 power 0. So this here we have just 1 here, and all the other cells are 0, right? So 1 into 2 power 0 will be 1, right? Likewise here it is having 2. So 2 power 1 into 1 will be 2. All the other values are 0, so equal to 2. Getting me? So we multiply this 1 with 2 power 1, and likewise all the other cells are 0. So if you multiply these values corresponding 2 power 7 into multiplied by 0, 2 power 6 multiplied by 0, so you multiply corresponding values. Ultimately you have only one in only one place. Alright. Likewise, if you want to store 3, you will put all these values as 0 and 1 here and 1 here. So 2 power 1 plus into 1 plus 2 power 0 into 1. So 2 power 1 into 1 plus 2 power 0 into 1 plus all the other values are 0. right? So this gives you 3. Likewise for 4, it will be all these values are 0. We have 2 power 2 is 4 here, right? And 0, 0. This would be 2 power 4. This would be the value 4, not 2 power 4. Alright, this is how computer stores the data internally. Now the question is, what is the maximum value int 8 can store? What's the maximum value int 8 can store? To determine that, we put the values 1 all over the place. All of these cells, we put the value 1. Now, how do we compute this value? What is the value, the numeric value of this, the decimal value of this? So, 2 power 7 into 1 plus 2 power 6 into 1 plus likewise 2 power 5 plus 2 power 4 plus 2 power 3 plus 2 power 2 plus 2 power 1 plus 2 power 0. This works out to number 255, right? So the value goes from 0, or rather not 0, 1 to 255, or rather it should be 0 to 255. Now this is unsigned values. If you give a sign to it, it goes from minus 128 to plus 127. Right, totally 255 numbers. So this is the idea behind how your computer stores the values behind the scenes. Now let's solve this problem, how to reduce the size of a Pandas data frame. Now we have imported the data frame and the values look like this. Now if you check the memory of the data frame, you can use df.memory usage function, set deep equal to true. This gives you 2.64 MB of space. So total memory occupied by this particular data frame is 2.6 MB. Now, if you want to consider only the data size, the memory size occupied by the data contained in DF. Now, remember, the data frame DF contains not just the numeric values, the information from the data. It also contains many other metadata because DF is a class, Python class. It contains attributes, it contains various stored values and all these things. So the total memory occupied is 2.6, but the memory occupied by the information, the numeric information contained in that data frame is about 1.1 MB of data from the data contained inside here. This is the net amount of data that this particular data frame contains. Now we want to reduce the size of this data frame. How do we do that? We want to reduce the memory, this part of the memory. How do we do that? Now the strategy that we will take is, say we have the data frame like this. We have the data frame and various columns exist here. Alright, we have various columns here. For each of the individual columns, one by one we will check for each of the individual numeric, that is both integer and float columns. We will check the minimum value and maximum value for each of the individual columns. Now suppose the minimum value of this particular column is 0 and maximum value is 10. This particular data can be stored using int 8 itself, right? Whereas if the value for this column, suppose the minimum value is minus 1000 and maximum value is plus 1000, let's say, all right, it might need a slightly larger data type, right? So depending on the minimum and the maximum value of each of the individual columns, we will change the data type from say int 64 to int 8 or whatever sufficiently required data type is for that specific column. Now how do we know how to find out what is the minimum and the maximum values required to store each of the individual data types? Now here int 64, what is the minimum value int 64 can store? This is the number. And how do we know this? We have a function in NumPy np.info, pass in the data type, and .min is going to give you the minimum most number. Likewise, .max is going to give you the maximum most number. Alright, now the procedure is the same. We check the minimum and the maximum values. If it is lying between, we will check from int 8. First we will check int 8. If the value is minimum and maximum, the minimum and max is lying within the range that int 8 can hold, then we will assign it as int 8. Assign that particular column as int 8. Likewise, if we have another column B, if the minimum and maximum is not possible with int 8 but int 16 can hold, then we will assign that particular column's data type as int 16. So that is the strategy. Now we don't have to manually do this one by one every time, manually individually check each of the individual columns. What we can do is we can create a generic function Here we have this function reduce memgen. What we are doing here is create all the numeric data types possible that we want to convert. We are considering int 16, int 32, int 64, likewise float 16, 32 and 64. So we will iterate through all the different columns of the data frame. First we will note down what is the memory required. Memory, that is the existing data frame, the raw form prior to conversion requires. So that we are storing it in start mem. Alright, then iterate through individual columns for all the different column types. So first we will go through the individual columns and we will check, okay, what is the minimum and the maximum value for that particular column, and if it is an int data type, we will follow this logic. If it is a float data type, we will follow this logic. So what is the logic here? We will check if the minimum value and the maximum value is lying within range of int 8 first. Then we will check if it is lying within the range of int 16, then int 32, then int 64, right? Wherever it is falling within the range, there we will assign the data type of that particular column as here. Suppose if it is falling within the range of int 16, then we will assign the data type as int 16. Alright, same goes for float also. So this is the whole logic. So we have defined a neat function. We can use this function for pretty much every other data frame that you are going to be dealing with. Yeah, so we are applying this reduce memory usage function. We are creating a new data frame df_o. Now the memory usage of df_o has come down from 2.664 I think to 2.02, and the actual data-based memory usage, the memory used by the data contained in the data frame, has come down from 1.1 MB to 459 KB, which is a significant improvement. Now this is a significant improvement in the amount of memory required to store the data of that data frame. Now this is a relatively smaller data frame. As the size of the data increases, the memory gains, the amount of gain that you will get from doing this data frame or data type conversion is going to be huge. And by doing that, all your subsequent data wrangling and ML model training operations is going to be much more faster. So remember this function, remember this method. This is a very useful hack you will want to do for all your machine learning or data science projects before you start training your ML model or do any type of operations on top of your imported Pandas data frames.